Our next speaker is Dr. Kilchan Choi. He has a new title, Assistant Director in Statistical and Methodological Innovations here at CREST. And he is our resident psychometric for the game. One of the resident experts in that area.
When I kind of asked from Greg, Casey, you need to talk something at the conference. And then I said, I'm not a game developer. I'm not a learning scientist. I'm not a content expert. Then what can I talk about it? I thought maybe I can talk about some question you can ask when you're doing the research to your psychometrician and methodologist. I mean, this kind of a talk may give you some kind of more question instead of some solution, I think. But this talk is kind of related to what Greg talked about it. And at the end of the day, you have some kind of idea about how can you do the research on this learning game and stuff. Because that's really important, because as a researcher, we kind of funded from the funding agency, and then that is our kind of the learning salary. So you can develop a really nice, the game, without any kind of scientifically rigorous kind of research result, you cannot get the funding for their development. So this kind of talk is kind of really helpful for you to do the research on the learning game. But this is completely different kind of a paradigm compared to the traditional kind of educational research. So as I said, my talk is kind of about what's the concern and issues while you're doing the research on a learning game, which is related to what kind of preparation you need for the research. Then what kind of concern on the psychometric part, and then characteristic of your data, and research design, and impact analysis. It looks really similar, psychometric and the research design and impact analysis. No, it's very, very different animal. So, and this is kind of preparation of research. As Greg said, let's build the game. And then you calling out your team. First, you need a learning scientist, and then maybe content expert, and the game designer, and the programmer, an assessment expert, and then maybe at the last, the psychometrician and methodologist. I know separate out those two, psychometrician and methodologist, but there's no space in this slide, so I had to put them side by side, but they are completely different people. I want to kind of emphasize that. And this is prep works I list, but most of you here, I'm kind of maybe angry about this is called as a prep work, but methodologist or psychometrician is that is done from other people, and then we just kind of take over from there. That's why I call it prep work. First, maybe you need to kind of select your content unit. And then you need to have the design of a kind of game architect. I mean, characters, and then I learned that the storytelling is really important in game. And then sequence of the presentation, and how many frame you need, and how many level you kid need to play, and what is exit level to the moving to the next level, and whether or not a plateau or graduation is kind of needed, and so forth. Then maybe the next thing is assessment selection. Whether or not you're do the diagnostic purpose, or formative purpose, or summative purpose. That should be determined before the game build. And then, as Greg said, telemetry is an important part. It's all these things is prep work for me. And then, okay, Greg called me, Casey, I need to talk to you. We kind of building up some games, and then he asks list of questions. Okay, this is the question. As a game developer, you can ask your psychometrician and methodologist. First, how many items we need? And then maybe total item, and then maybe item per construct, then how many construct you need, and then maybe timing of assessment, before you need to measure before gameplay, or during the gameplay, how many the time you need to measure during the gameplay, or after gameplay. And what type of item you need to administer, the multiple choice, or game embedded, and simulation. I mean, a lot of questions. Even more, what is your outcome data? Is it binary, is correct or incorrect? Maybe nominal or ordered? Or not only that, that's kind of proportion or rate might be interested in your game. Or frequencies are important maybe. And then speed is also important too. So there's many different type of outcome. And then interestingly, you're gonna do the cross-sectionally, or you can measure the over time, longitudinally. Maybe you can do the adaptivity of your measure and then individualized kind of treatment. You need to maybe go to the longitudinal trajectory is important rather than the one-time point. And the traditional psychometric question, reliability. This is a little bit different. Because how can you define the reliability in the setting learning is occurring in your system? So what type of reliability coefficient need to be estimated? Typically the Cronberg alpha or retest reliability or even the general ability coefficient. If the learning is happening in between, then maybe you screw up your reliability coefficient, right? And what is the option to improving your reliability? I mean, maybe you just want is kind of throw out more items, but I don't know that's going to pass option. So what kind of option you have to improve your reliability? And then this is kind of a data feature. I think that this is really important because a lot of methodology and the psychometric work and impact analysis is kind of proposed in the traditional way. And then but the data features is not fit to our current, old traditional methodology at all. Because first thing is kind of data is gigantic. We call it big data. And the big doesn't matter to me as a psychologist, the psychometrician or methodologist. Big data is okay because we have a huge capacity of the computer. So millions of cases or billions of cases doesn't matter. But key problem is that those three things. Dependency. Dependency is kind of what is a big deal? But dependency is kind of a really troublesome for statistician. Because correlation over time is a natural thing in this game, learning game setting. And then construct is we have multiple construct, and the construct is correlated. If it's kind of independent, that's really simple. But we have multiple construct and then correlated. And correlated not only among the most construct, but also correlated over time as well too. But also, when you do the research on classroom-based or school-based, and the kids are clustered or nested within some teacher and classroom and school, there's multiple layers of dependency. That's really troublesome for the statistical model. And then, interesting problem is the different pattern of missing data. Because students start with a different level of game, and then stop at a different level. So by design, there's a good chunk of data is missing. So how you deal with that, the missing data issues? And then since we have the all log data, and maybe possibly we have much noise in the data. So we might have really good filtering system, which data is usable or not. Otherwise, all the telemetry log data might be not meaningful. So we need to have that kind of a feature. And then research design on top of that. You want to do the experiment? You want to do the quasi-experiment? Or just a randomized trial? Or a randomized cluster trial? You're going to kind of implement the study to the classroom or school? And what is the randomization level? The individual has a different treatment? Or the classroom has different treatment? Or school has different treatment? That's all need to be answered. And you want to do the pre-test and post-test design? Or just kind of post-test? Or you do the internal measure or external measure? And then how many students you need? How many classroom you need? How many school you need? to have the appropriate statistical power. The calculating statistical power is it's kind of a, somehow it's kind of easily asked. I mean, for example, Harry always told me that, Casey, what is kind of statistical power for this kind of design? I mean, that's a simple question, but statistical design, this is kind of retrospective calculation. So if you don't know about your impact model, you cannot calculate the power at all. So that is a really kind of a big issue. And then another kind of, this is another problem too. Given that there's aptitude and treatment interaction, or attribute and treatment interaction, and we call it the mothering effect, the design is really difficult whether or not you're going to that aptitude or attribute as another design factor, or just use it as a covariate or something, as an interaction term. Maybe another kind of an interesting research question is you can do the feasibility study. If you have a luxury to have a small pilot study to validating measures and system or not. And your research question, and then the measurement model and impact model. Impact model means estimating that the game effect compared to the control group is aligned together. And sample size is large enough to apply to really complex, the psychometric model and impact model. As John said, maybe the very small sample size, you cannot do much at all. You just do the frequency or some simple t-test. That completely ruin of your beauty of your game, right? And as I said, there is another moderating and mediating factors related to this study. And so all these questions, the key psychometric model address those kind of questions. And this is kind of trend of old psychometric model and the current psychometric model. From the observed data to the latent variable, which is kind of reduction of a large observed data to the smaller number of a construct, and then dealing with the measurement error of the observed data. And as I said, there's kind of not only single construct, but also multiple construct. We call the statistical univariate model to multivariate model. And then we deal with the dependency in test-led or subscale of your score or over time as well. And then simply from the 0-1 binary data to the categorical data as well. And in terms of latent variable, people kind of deal with the continuous factor from the 1950 or something. And then these days, people deal with the binary or categorical factor, whether or not that some attribute is pass or fail, and things like that. And this is kind of list of the psychometric model. And I didn't talk about this model at all, but there's some kind of a tool you can use. And from the exploratory confirmatory factor analysis is kind of an old tradition for validating your measure to whether or not your construct is measured by your item well or not. And then, for example, linear logistic test model is 1970. Fisher has proposed whether or not your item or item difficulty related to the item feature. And all kind of from the IRT, univariate item response theory, to multivariate the item response theory. And the last one, dynamic factor analysis, is kind of proposed to, over time, you have a construct is changing over time, so how you deal with that issue. So other kind of more psychometric models like this, multidimensional item by factor model, and the Lee, the two-tier item factor model is expert. And diagnostic classification model as well is kind of frequently used. And we have some kind of new hierarchical multidimensional diagnostic classification model. I mean, this is a long word, but I mean, we have some kind of new psychometric model as well too. And then you use this model for this game, learning game setting, and then even kind of a large scale assessment as well too. And there's kind of a lot of impact model. It's kind of a data is nested. And the mediation is kind of key factor. In the IES proposal, you need to use this mediation analysis. And then there's a multi-level, which multi-level means the student nested in classroom, classroom nested in schools, and school nested in district. So you need to deal with that nested structure as well too. So there's some kind of model how to deal with the impact model. In that case, impact model is kind of, as I said, there's a psychometric model, impact model is different. So you're going to go with the two-stage. You first do the psychometric measurement model and then do the impact model, or you're going to integrate those two. So that's kind of a big thing as well too. And then to decide that kind of a decision, your data support that kind of a model is the most important. And whether or not the estimation computation is available or not. And if kind of SPS can do it, to easily do it, but usually that's not the case. Okay, this is conclusion. And teamwork and communication is the most important thing. You need to talk your psychometrician and methodologist when you design the study. And then you need to ask the right question to the right member of your team. And as I said, there's most likely there's kind of a lot of model is available right now. So you need to pick up the right tool to address your research question. And then you kind of are really excited when you're developing the game and then collecting data as okay. After you collect data, your job is done pretty much. So it's kind of passed out the data to your psychometrician and methodologist, and then just kind of keep pushing it. Give me the result. And then they don't know the game well, so I mean, they kind of less use of data, but try to make a full use of your data. And then a lot more time and support to your psycho people. It's Greg call me always psycho people. So that might be the reason I can share today. Thank you.